Hello and welcome to my YouTube channel ChemWis. In this video we are going to discuss PCC oxidation. In this reaction, primary and secondary alcohols in the presence of PCC, which is pyridinium chlorochromate, in DCM as a solvent, get oxidized to aldehyde and ketone respectively. PCC is also known as Cornforth reagent. PCC oxidation is a mild and selective oxidation which prevents over-oxidation of primary alcohol to carboxylic acid. Mechanism of PCC oxidation. Alcohol acts as Lewis base due to the presence of lone pair of electrons on oxygen, while chromate as Lewis acid due to electron deficient chromium. Attack of oxygen of alcohol on chromium and breaking up one of the two chromium oxygen pi bond lead to the formation of this adduct. Intramolecular proton shift like this gives anion of dihydroxy alkoxy oxo chromium 6 chloride, which removes chloride ion like this to produce chloride ion and chromate ester of alcohol. Alpha proton abstraction by chloride ion and subsequent formation of carbon oxygen pi bond and breaking up chromium oxygen bond gives HCl and anion of chromous acid to produce aldehyde or ketone. Examples of PCC oxidation: 1-propanol, benzyl alcohol, 2-propanol and 1-phenyl ethanol when undergo PCC oxidation produce propionaldehyde, benzaldehyde, acetone and acetophenone respectively. Let's have an interesting example of citronellal. When it is oxidized with PCC, produces corresponding aldehyde which undergoes ene reaction to produce a allylic alcohol called isopulegol, which can further oxidize to cyclic ketone. Under basic condition, this ketone isomerizes to more stable alpha-beta unsaturated cyclic ketone. In the presence of buffer, the reaction stops at aldehyde stage and we get aldehyde as the product. Lupinol. When it is oxidized with PCC, produces lupinone. A tertiary allylic alcohol in the presence of PCC undergoes oxidative transposition to produce enone. This reaction is called Babler oxidation. Overall, we can say that in Babler oxidation there is 1,3 shift of OH of tertiary allylic alcohol to produce primary or secondary alcohol, then oxidation of alcohol to aldehyde or ketone. For example, when 1,5,5 trimethyl cyclohex 2-ene-1-ol is treated with PCC, produces 3,5,5 trimethyl cyclohex 2-ene-1-one. We can see that it would have been produced by 1,3 OH shift to produce 3,5,5 trimethyl cyclohex 2-ene-1-ol, followed by oxidation of secondary alcohol to ketone. I am not going to discuss more details about the Babler oxidation as I have made a separate video on this topic. The link for the same can be found in the description box of this video. That's all in this video. Please subscribe my channel and press the bell icon if you like this video. Thank you very much for watching this video.